looks like we're live. Man, I got like, I don't know, I guess my voice is gone a little bit. But, yeah, we're gonna go ahead and work on matrices. So, let's just get back into it. Alright, we have our original matrix, which looks like this. Yeah, you can see that. 0, 0, 1, 2.000, all these freaking zeros, man. Yeah, we're gonna augment it, right? That's our augmented matrix. 2, 1, 3. All right, 1, 4. Cool. 4. 1 more 0, 3, 7. All right, we're gonna make a pivot before we do the forward elimination. Our pivot candidates, the largest candidate is 2, so we interchange row 1 and row 3. Right, so we're gonna go from this. This is our augmented matrix. That was a really bad line. Let's redo that. Augmented matrix, and we're gonna pivot our values so that the highest value is at the top. And let's rewrite all of that, because why not waste time with all of this dumbass, you know what I mean? But hey, it's looking good. It's a whole lot of fun. We're having a great time out here, so why bother with the concerns? America is going to war. May God save us. I'm not particularly happy with the decisions made by our leaders, and the way that the consequences of their actions trickle down to us, normal Americans, is rather egregious. The consequences are unforgiving. And hey, brother, I'm just trying to make a living, start a family. You know what I mean? You know what I mean? But what does it matter? What does it matter? Bro, get the Nez and the .com fucking bullshit out of here. Okay? Nobody gives a shit. Nobody gives a shit about whatever your fucking link is. Alright? How do I delete it? Get it out of here. How do I delete it? Add to block list. Yeah, get the fuck out of here. Does it not delete? Boom. Gone. Gone. I cannot stand that shit. I don't know if it's bots, what it is, but I don't care to find out. Alright, gone. Decimated. Alright, back to the matrix. So we're going to partake in the elimination. Okay, and so first, to get our constant, which we multiply by our respective equation, which we are going to use to eliminate the leading coefficient in our, the equation that we determine. In order to get that, we're going to take yeah, okay, so this is our new pivoted matrix, like this. That's right, minus R1. We're going to multiply by half to get 1. So we're essentially going to do R2 is going to go to R2 minus half times R1, indeed. And what that looks like is, we're not going to do the subtraction, but we're just going to do half times R1 at the moment. Yeah, right. So that's going to look like R2 minus yeah, half R1, which is going to be 1 plus what, 3 halves. I guess I'm not going to, that's fine. That's fine. Plus 2 plus 7 halves. Okay. And now that's going to look like everything here remains the same. I'm not going to put all the leading zeros because it's absolutely unnecessary. It's going to look like that. Now we're going to do 1 minus 1, 0, 3 halves minus 1, which is going to be 2 halves. 3 minus 2 is 1 half. But 3, wait, what do we have? Oh, 2 halves, so negative 1 half. 1 minus 2, negative 1. And 3 minus 7 halves, that's going to be 6 halves. That's going to be negative 1 half. Okay. Yep, negative, yep, okay. Beautiful. So now to, okay, to eliminate this leading coefficient, we're going to take R3 is going to transform into R3 minus 0.0001 divided by 2 R1. Right. What is that? I don't know, maybe I shouldn't be so retarded and I could figure it out in my head, but let's go ahead and cheat and use the calculator. So equivalates to equals, or I'll write it all out, minus 5e to the negative 5 R1. Okay, it's a better way to put it. So this is going to equal R3 minus, let's go ahead and calculate those values, which is going to be, and this is all multiplied by R1. So 5e to the negative 5. Can you see that? No, you can't. I don't know what to do. Maybe it's the exposure, but I'm not going to change any of my settings. So, oh, there you go. It's, angle helps. So let's get on with it. 5e times 2. Wait, no. 5e times 2. Well, right. That's going to give me 1e to the negative 4, of course. 5e to the negative 5 times 3. Right, so 0.0001 plus 1 point to the, so 0.1234 0.0015 1 2 3 4, yep, plus times 4, 5e to the negative 5 times 4, 2e to the negative 4, so 0.0002 plus 7 times 5e to the negative 5 times 7. That's going to be 0.00035. Now, isn't that just gorgeous? Absolutely beautiful. Okay. Cool, now we can do all of this. So that's going to be 0 and 2 minus 0.00015. Yeah, okay. 1.99985. 0.5. Cool, love that. 3 minus 0.0002. Yep, love that. 2.9998. And 4.0001 minus 0.00035. Cool. Okay. Love all these decimal places. That's just super cool. 975. But at least we've gotten the point across. So, yep. Okay. Okay, so let's do another pivot again. We're going to consider our pivot candidates, which is going to be negative half or 1.999999999999985. We want to choose the larger out of the two to be in the higher position. So we're going to head and move forward and swap out row 2 and row 3. That's going to come down here and it's going to look like this. 1.99985. I should have spaced this a little better. Let's do it. Let's write out this row before I write out the other rows, because this is 998 3.99975. Okay. 3 4 7 0 negative half. Negative 1, negative half. Okay. So now row 3 is going to go to row 3 minus so that which is being multiplied. So negative 1/2, or we'll just say negative 0.5. All right. Negative 0.5 divided by 1.99985, because that's gonna become that exactly equals. Yeah, just to make sure that we maintain our equation, I'm gonna draw it like that. So negative 0.5. Maybe you can kind of see that. Divided by 1.99985. Okay, so this equals, let me do that. 0.25. What, do I write this whole coefficient out? Value rounded to 5 for clarity during intermediate steps. Shit, man. I guess let me do it. 0.0187514 times R2. Alright, sure. So our new matrix becomes 2, 3, maybe a little more space. 2, 3, 4, 7. I hope I have enough time to finish this. Alright, 0.2. Alright, so this that also remains to 1.99985. So we already got these in the position that we want them, with leading with a 0 here. We just want a 0 here and a 0 here, but right now we have a negative half, so we need to remedy that, and that's what we're working on now. 3.99975. You heard? Okay, maybe I should record, but I guess I didn't start recording, so should I even start recording now? Probably not. Fuck it. Alright, so this long number here multiplied by R2, which is going to be 0, 0. We can skip that. Let's multiply that times 2.9998 equals, yep, that number. And then now we say negative 1. Well, we did a subtraction. We want to actually do an addition. Because no. We do want to do a subtraction. That's my bad. Let's keep it subtracted. Negative 1 minus this number. Alright, negative, yep. Negative 0.2499. Maybe write that a little bit better. And I did exactly what I didn't want to do. So here we go again. You know what I mean? You know what I'm saying? Negative 0.2499. Sure. Okay, I'm not a numbers guy today. Times negative 0.5. I did the wrong number. This number times 3.99975. You heard? That number, now negative 0.5 minus that number equals 0.5000013. Is that too many? 1, 2, 3, 4, 5, 6. That is too many decimal places. Alright, and that's where we stop it. Upper triangle matrix, we saw a variable starting from x3. Okay, now we're going to, so we have our simplified upper triangle matrix. Our upper triangle matrix. So now we can go ahead and use the ideal method of solving, which is back substitution. Excuse me. So, excuse me. How do we x1, x2, x3? What's our variables? Morty. What's our variables? Okay, so we have 2x1 plus 3x2 plus 4x3 equals 7. We can write like 1.99985x2 plus 2.9998x3 equals 3.99975. And then, okay, negative 0.24999 equals x3. Okay, so we can directly solve for x3 off the bat. Again, negative 0.24999 equals 0.50001. And I forgot to put the x3 again. Alright, perhaps it's time for bed, but we gotta get this finished, so we persevere. Okay, so we can go ahead and say x3 equals 0.50001. That's a 4. Divided by negative 0.24999 equals negative 2.00012. Okay, now we got that. So now we say x2 equals, I'm just going to go ahead and do it. You know, I have the equation here. I have x3 here, so I'm just going to plug in my value for x3 here. I'm going to subtract that, right? Yeah, subtract that from this number, and then divide that sum by this coefficient here. Damn, is that really so hard to see? Let me look real quick. Well, that doesn't even do justice. Might be really hard to see. Hopefully not. Hopefully not. Hopefully not. Hopefully not. Yeah, get the fuck out of here. That's actually not too hard to see. That's good. Cool. Cool, I love you guys. Cool. I love you. I love you. Okay. I love you. Alright. Alright, so 2.9998 times that result is a stupid ass number. 75 minus, I guess it'd be plus, because, yeah, plus, wait, yeah, is that number divided by 1.99985 there, boy. Yeah, you get this number here. That's all pretty crazy looking. 2, 3. Yep. Yard. All right, now last thing we got to do, ladies and gentlemen. 3 times that number plus 4 times x3, which was the negative 2.0000000. Now that number is a whopping this number, and I'm going to take 7 minus that number because it's positive. Yard. And we get a real small number now, and I'm going to divide that by 2, and now I get that x through x1 now, because we're solving for x1 there now. This approximately equals negative 0.0001. Bang! Bang! That's great. Each elimination step, identify the pivot candidate, determine whether a row interchange is needed, and perform the row swap when necessary. Use back substitution to solve. Alright, that's it. On to the next question. I didn't really I don't know. Maybe, hopefully I represented everything that they asked for, but fuck, I ain't gonna do anymore. That's it. Bang. Yeah, whatever. Alright, cool. Tight. Hope you followed along and you know exactly what's going on. You better. Alright, consider the following coefficient matrix. A equals 4, negative 1, 4, negative 1, 1, 2, 5, 2, 1, 2, 5, 2, 1, 2, 4, 1, 2, 4, 1, 2, 4. Alright, we got it there. Use LU factorization by hand. Decompose A equals LU, where L is a lower triangle matrix with 1 on the diagonal and U is in the upper triangle matrix. Use your LU decomposition to solve the system for the following right-hand side vector. And the vector using Cholesky factorization, find an upper triangle. Alright, I don't really know what that shit is. So we're about to figure it out. Error due to rounding, using pivoting to improve results, tridiagonal system. None of these, no. So we're on to chapter 10. Blah, blah, blah. LU factorization. Recall that the forward elimination step of Gauss elimination comprises the bulk of computational effort. LU factorization methods separate the time-consuming elimination of the matrix A from the manipulation of the right-hand side B. Once A has been factored or decomposed, multiple right-hand side vectors can be evaluated in an efficient manner. LU factorization. Upper, lower, what? Forward, substitution back. LU factorization in 2 steps. Factorization to decompose the A matrix into a product of lower triangular matrix and an upper triangular matrix has 1 for each entry on the diagonal. L has 1 for each entry on the diagonal. Substitution to solve for X. Gauss elimination can be implemented using LU factorization. Okay, sure. Makes a lot of sense. Makes a lot of fucking sense. Alright. Elimination AX equals B can be rewritten as LUX equals B using LU factorization. The LU factorization algorithm requires the same total flops as for Gauss elimination. The main advantage is once A is decomposed, the same L and U can be used for multiple vectors. MATLAB's LU function can be used to generate the L and U matrices. Gauss elimination as LU factor. To solve, first decompose A to get LU. Set up and solve. Decompose A to get LU. Set up and solve L, where D can be found using forward substitution. set up and solve where x can be found using backward substitution. I mean, bro, how you not gonna give me an example? Because we did back substitution, but what the fuck is forward substitution even? Am I missing something? Wait, where you substitute it first without doing the decomposition? Graphical methods, determinants. I'm not seeing it here. Kramer's rule. Kramer. Determinant function in MATLAB. Gauss elimination. Alright. Forward eliminate starting with the first row. Add or subtract multiples at blah blah blah. Yeah, back substitution. Alright, I guess. Alright, I guess. Baby, come back. You can blame it all on me. Baby, come back. It was always your fault. Okay. Okay, I'm a numbers guy. Sorry, I played a little bit of the computer audio. I should really just mute that for real. Why don't you guys chat in my chat? Say something. For the love of God. Alright, LU factorization. We decompose A such that A equals LU. We use Gaussian elimination to find U and store the multipliers in L. And store the multipliers in L. What? Elimination to find and store the multipliers in L? Wait, what does that even mean? R2. Wait, what? Okay, so let's. Well, is it decomposition? Is this what we consider it? Let's decompose A. I'm gonna call it a Gaussian elimination for simplification. Decompose is a silly term. So what that's going to look like is R2 goes to R2 minus 2/4 times R1 equals, alright, equals R2 minus, we do it like that. So 2/4, 1/2. 4 divided by 2 is 2, so obviously it's gonna be 0. Negative 1, negative half. Let's go on 0.5. So negative, negative 0.55 minus negative 0.5. It's just gonna be 5.5. Or this is me. See, that's the whole all that. That's the thing. Or I could actually no. Let's do it. Let's do it. So R2 minus 2 negative 0.5 0.5 positive 0.5, right? Yeah, we don't have, that's not specified. Okay, and then R3 goes to R 3 minus 1/4. Oh man, I keep writing this bad. Yeah, it's looking good. R1. Okay. Alright, this equals R2 or R3. Shit. R3 minus 4 divided by 4 is 1. Negative 1/4, negative 0.25, 0.25, 0.25. Okay. Yeah, we'll work in decimals for this shit. Okay. No, because that comes next. Okay. Am I seeing what's going on here? I think I'm seeing what's going on here. Let's just continue and figure it out. So we got 4, negative 1, 1. Now we got 2 minus 2 is 0. 5 minus 5 minus negative 0.5, 5.5. 2 minus 0.5, 1.5. Okay, cool. Okay. We got 0, 1 minus 1, 2 minus 0.25. Wait, 2 minus, so plus, so 2.25. And then 4 minus 0.25, 3.75. Yeah, okay. Okay, interesting. Alright, that's our new matrix after the Gaussian elimination. Let's proceed forward. Now we're going to have R3. We only have one more 0 to acquire here to have an upper triangular matrix. R3 is going to go to R3. Oh man, that was like a B. R3 minus 2.25 divided by 5.5 times R2 equals R3 minus what is 2.25 divided by 5.5. Okay, this is that number, as you can see. Oh, it's that number. It's kind of cool. Check it out, guys. All right. So that number times 5.5 should be 2.25, right? So 2.25. And that number, not that number, but that number times 1.5 is this number. Jeez. 61363636337. That's a lot of fun. Alright, so now our new matrix is 4, negative 1, 1, 0, 5.5, 1.5, 0, 0, 3.75 minus that long ass number is 3. And is that, now where does that come from? So that's right, but where does that come from? 0.4091. What? Because 22, my boy, what? Alright, we decompose A such that A equals LU is Gaussian defined given. Right, 2 over 4. R2 minus 11A 32. Right. 3 1 3 6 3 or 1 3 6 4. I'm gonna stop it right there. So that is our final upper, which we can call this U. I'll write that differently. But I'm having a hard time understanding what the L is. Like, I almost got it, but then there's that factor. It doesn't make any sense. R3 minus what? Equals. Like, sure, just to make a whole. Yeah, that's perhaps true. And that makes sense. But where does that number come from? Oh, no. Yeah, shouldn't it be this number? Whoa. Whoa. What the? Oh, okay. So it's like, okay. So 2/4 equals 0.5. 1/4 equals 0.25. 2.25 divided by 5 equals 0.4090. How many did I do here? 4. I'm gonna just do 4 here. 491. Yeah. Okay. So we got our upper triangle, and then our lower triangle equals so 1 0.5 0.25 1 0.4091 1 0 0 0. And that's our lower triangular matrix that we need for this, whatever this weird process is. But I guess we're figuring it out as we go. And now we're about to understand its actual application in solving for the variables. So, solving the system, forward substitution in UX equals back substitution. 5 1 4 6. Y1 equals 5. Wait, like, actually, what? For B1 equals, is that what I had? Oh, for B1. Okay, so now let's define our vector matrix, which is B1 equals 5 4 6 5 4 6. That might be hard to see. I'm drawing that really small. And then B2 equals 2 1 3. 2 1 3. Okay. All right. What time is it? I gotta have this in by 11:59, but I got time. Okay. Solve the system X equals B for the following right-hand side vectors. Man, decompose A equals LU, where L is a lower triangle matrix. Now we can do that. AX, B. So now we can go ahead and do AX decompose to get, so let's solve interesting. What happened? Oh, maybe nothing. How's the quality? I think the YouTube quality is worse than Kit quality, honestly. Doesn't look very good. Go to live. There we go. There we go. There we go. There we go. Viz Lumen. Maybe the Viz Lumen's too big too. I think it is. Yeah, that's too big. I'm gonna have to fix that sometime, but not this time. Okay. Alright, for B, what the fuck is the T for? What's the T for? B1. Y1 equals 5. And this is the forward. Solve forward substitution. Ly equals B. Solve Ly equals B. This is forward substitution. Okay, so y1. So y1 equals 5. y2 equals 5 minus, and that's a subtraction. Or not 5 though. Right, cause and where are we getting this from? Here we're doing L, so Ly equals B1. Okay, wait a second. So that did define it. Wait, so Ly equals B1. So Y1 equals 5. Y2 equals 4 minus L, 0.5 times 5. And that's it. Equals. And then Y3 equals 6 minus 0.25 times 5 minus 0.4091 times the answer to this, which is 2.5. 4 minus 2.5. 1.5. 1.5. Huh, interesting. Equals 6 minus 0.25 times 5 minus 0.4091 times 1.5 equals 4.13635. Okay. Alright, sure. We're gonna do ux over here. U, whatever, x equals b, or equals y. Ux equals y. Ux equals y. Very, 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 very interesting. X equals y over u, right? Y over divided by 3.164. So weird. So x3 equals that divided, no, it'd be that divided by that. That's weird. 4.13635 divided by 3.1364. This number divided by 3.1364. Yeah. Alright, sure. 1.3188. I'm gonna leave it there. X2 equals, they're all just simple. No, it's not a simple division. Now we got 1.5 minus 1.5 times. What the fuck? Minus 1.5. There we have nothing. 1.5 minus 1.5 divided by 5.5. What the fuck? So 1.5 minus 1.5 times, because that's, so we got 1.5 here, 1.5 here. That's u, ux, 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 ux. 1.5, 1.3188. Yeah, sure. I guess that works. All right, and for x1 equals, so 1.5 x1, 5 minus, so 5 Well, now that doesn't make any sense, but sure. 0.9420. Yeah, we'll go to 4. Well then, okay, 4. I'll just leave it there. Money, fuck it, okay. Alright, now we do the same for B2. How weird. This is a really weird process. It's a weird process. Man, I think I need some water, some H2O. Oh, I'm running out of time. Really running out of time here. say then? What sense does that make? Yo. Whatever, bro. Eat shit. Gamma numbers guy. Gamma numbers guy. Alright. So all of this was wrong. That's fine. I kind of gotta tear this out. I don't really want to, but like, I don't know how else to do work. I gotta see this. Alright, because I gotta reference it. Sharpen a little bit. Hell yeah. Hell yeah. Hell yeah. Alright. B2 equals 2, 1, 3, bitch. Okay. Ly equals B2. So now, we have our matrix here. Ly equals B2. So Y1 equals 2. Right. Y1 equals 2. Y2 equals 2. Y2 equals 1 minus 0.5 times 2. 1 minus 0.5 times 2. 0.5 times 2. 0. Y3 equals 0.4091. Duh. 3 minus 0.25 times 2 times 2. So it's like 3 equals 3 minus y1 minus 0.25 times 2 minus 0.4091 times 0 equals 2.5. Yeah. Okay. And ux equals y. So now from this, we start with x3. X3 corresponding to y3. So let me do this. Let me go x3 equals 2.5 divided by 1.1364. And that's just where we start. 0 minus 1.5. 1.5. 0 minus 1.5 divided Yeah, we always do. Well, in that case, it wasn't necessary, so it's a little odd. Minus 797. Right, the previous value divided by 5.5. So 0 minus a factor, a constant. Is that where that comes from? Is that coming from? It just simply must be. And then that's just straight up like that. Like there's no multiple. Why is there no multiple that time? Divided by 4. Because those are all 1s. Because those are 1s. Negative. Negative. Minus. Minus. It's all subtracted. So this 1.5, 0.7971 divided by 5.5 equals negative 1.5 times 0.7971 divided by 5.5. Negative 0.2174 x1 equals 0. 2.5. 2.5 minus. Fuck. So 2. I already did the 2.5. I meant 2 up here. Can you see that? Yeah. Minus. Previous value. And even previous value. 2 plus 0.2174 minus 0.7971 divided by 4. 0.3551. Now I have to go to MATLAB and do some shit. We'll do that in a moment. It's 11:15. This is due 11:59. Give it to me straight. Cap. Give it to me. 6, 3, 2.